Okay, guys, good morning. Welcome back to my YouTube channel. Again, this is your Sadiq Santos Gavilan Jr. Or you can call me Santos Bay or Santos Abe. Guys, let's continue this series of tutorial for this system. By the way, our system now is supply and exhaust fan ventilation for genset room. Right. Guys, let me show you an example of this. Actually, I'm also connected to one of the colleges here in Legazpi City. I am a part-time instructor here teaching some students in controls, okay? So let me use one of my students design for a generator ventilation system. Okay, actually this is done by my students in controls. Shout out to Ray Asopardo. Okay, let me share this graphics. Okay, so this is the output of the student for the same system. Right now, let me see. Okay, now as per our updated sequence of operation, I have added their dampers. Okay, so let's say this is the dampers from the exhaust. Okay, then also we have a damper in a uh, supply. Okay, so actually what he did was to also put some bag filters here. Okay, so that it will try to filter the air being supplied to the generator room. Okay, so I can say this is a very good graphics design for this system. Okay, so this will be our system, the one we are creating the uh, control logic program. Okay, so let me go back to my control logic. Okay, now we updated the sequence to prevent insect and birds entering the generator room. Okay, a motorized damper with actuator was installed at the SF intake and exhaust opening. Now, actually, this one is an open and closed damper. Okay, this is not modulating. So only open and closed. BMS will be the one to control the opening and closing of this damper. Okay. Now, actually, in generator room, there will be another set of dampers related to maybe related to fire alarm system or the clean agent or our FM200. Okay, but those dampers will be controlled by the particular system like fire alarm and clean agent or FM200. Okay, now so let me continue this control logic. Now, as I said previously, that actually what we are doing here, when we exceed a certain what you call this one, a certain number of hours for our equipment, when it is accumulated that number of hours, then it should stop automatically. That one is being represented by this logic. Now we don't need this logic in this generator room because we don't want our fans to stop when the generator sets are running. Okay, so we need to remove that one. So what I'm going to do, okay, so I need to remove this. Okay, delete it. Then I think I need to remove this end. Okay, so that I will just use the output of this end gate and connect it to the input here. Okay, now likewise I need to remove also that logic here. Okay, then I need to remove this end gate here, then connect this end there. Okay, now what we are just doing here is we are trying to monitor the uh, run hours. Then we remove the uh, automatic stopping of the fan when it reaches the set point for the run hours. Okay, now I need to implement the additional control here. Now, as I said, uh, okay, we already included the delay of the equipment. Then we need to include the damper. Okay. Now, okay. Now, when when generator runs, okay, when genset run, that is our control to open the damper. Okay, now what I will do here is just create a simple block. Okay, this time I need a DO, digital output block, to start my supply and exhaust dampers. Okay, now let's say I have only one supply and exhaust damper. Okay, so just for the sake of doing a simple logic. Okay, so let me identify this one. So this one is SF damper CMD. No. Open, let's make it a little bit CMD. So this is my open damper command. Then I need to bind it. Okay, I hope we still have that is in module 421. Okay, we still have some available output terminals. Okay, no need to put the then I will copy this, Control C, Control V. Okay, then I will say this one is for the exhaust fan. Okay, let's put it here somewhere. Okay, now okay, so this one is for the EF. Okay, then change the binding here, bind it to 4. Okay, very easy. Now, when generator runs, okay, then, okay, I will just use end here. I need an end black. Okay. Now, the output of this, I will try to use for both of the. Okay, so when generator set runs, okay, then okay, then I need to use the when my EF is in auto and there's no fire alarm and there's no trip. Okay, so I will use another end here. Okay, I will use another end. Okay, then the output of this I will use here as the input here. Okay. Then this is the condition where, okay, this one. So this is the condition where my exhaust fan is in auto, there's no fire, and there's no trip. Okay, so this is the one. Then this is the one. Okay, so I will create a node here. Create node. I'm going to use that condition. If it is being met, then that is one of the conditions to run the. Then likewise, I will look automatic. Okay, then there's no fire, then there's no trip. So this one, I will create a node here. Okay. Then use it for my logic. Okay. So this one will represent the damper control. Okay, but I will say you don't need to don't start the funds when we have not received the open status for the dampers. Okay, so likewise I need to create additional. Okay, so where we can insert this. Okay, we will insert it here. Simple block DI, digital input. Okay, so I need additional inputs. This time I will identify this as the S damper open. Okay, so I need this status before I will start my let's see. Okay, let me use this one. Okay, I will start at the bottom. Okay, so okay, then again I need another status, Control C, Control V for my EF. I have the EF damper status there, then I will say this will be for my EF. Okay. So if you will name your or you will specify your identifier this way, it will be very easy for you to that one has 10. Huh? Okay, I use 8, then I will use 7. Okay. Okay, now let me save. No, not yet done. Okay, now as I said, I will start. Okay, I need to. Okay, so let me pull this a little bit. Then I need to remove this node. Then I will create another end block here. Okay, so that I can include the. Okay, now it's very easy. So this one is for SF. So I'm going to use this for my, okay. Now, as I said, guys, if you are doing the control logic program, there are so many approach that you can use, okay? So you are the programmer, then you can do different approach, okay? As long as it will, just make sure that it will, what you call this one? Okay, I will remove this. Delete node. Okay, so let me adjust this to here. Put it here. Okay. Then insert another end block here, just like what I've done in the. Okay, so now as you can see, the logic is getting a little bit complicated for beginners. Okay, but for expert, of course, this is not complicated for expert. Okay, so but I'm not saying I'm an expert to this one because, as I said, I just tried to study this on my own. Then maybe someone out there is really an expert on this one. So maybe he can give us a hint or idea how we can improve our logic. Okay, so now this is the final logic for the above sequence of operation. Okay, now let's try to save it. Save. Okay, there's no error. Then we will see when we try to simulate. Okay, so there's no problem. So when we simulate, let's execute. Let us give the EF run status. Then SF, I mean the hand of auto. It's already in hand of auto. Okay. Then let's say there is a generator set run. Okay, then damper already is trying to open here because the damper should open first before we can start the fan. As you can see here, the fans are not running. Okay, I mean the fans start stop command is not yet given by our control because it's waiting for the status of this damper. Okay, so let's give the damper EF then SF. Okay, as you can see now the command for the funds are given by our control logic program. Then let's say our SF is running already. Then our EF run. Then again, our accumulator will try to count. Okay. But this time, as I said, we need to make, we will adjust this one. Maybe that will be 500 hours. Okay. Anyway, so when there is fire, this funds will stop. Okay. There is fire. Why it did not stop? Okay, I close it. Then again, there was some time delay there. Okay, now why we have a problem here? So what is the problem here? Fire alarm. Okay, so I have one problem here. Why this one did not stop? Maybe I did not use the fire. Where is the fire here? Fire alarm. Okay, there's fire. Then I use it there. Okay, then this one. Aha, I did not use the fire alarm here. Okay. So I need to use the fire alarm here. Okay. So that will be our, okay, our part 6. Finalizing this, finalizing. Maybe you can tell me what was wrong with this logic. I think that what is the problem here is we have to use this fire alarm logic here. Okay, this fire alarm logic is this one. Okay, okay, this one. Okay, I did not use this one. Actually, I have to use this genset. Okay, now I need to use this. I need to tap this one from here. Okay, so I need to tap this one from here. So we can options, edit. Let's go back. So let's remove this node. Delete node. Okay, so we need to tap it from here. Okay, so if you have the capability of simulating, as you can see here now, execute. As you can see here, there is fire alarm. Okay, there is fire alarm here. Where's the fire alarm? Okay, there's a fire alarm there. Then as you can see, our our SF also stop. Okay, let's remove the fire. Okay, again, now it's okay. So guys, thank you for watching this part 5, and I do hope I have given you already ideas. How are you going to use blocks in controlling the equipment? Okay, as I said, this will be detailed programming. Then maybe I will try to offer some alternative solution for doing this control logic program. So once again, before I will end, God bless us all. Let's all be safe and bye for now.